All right. Good morning, everybody. I hope you're doing well. A few things to say to you. Let's go to the iPad. Now, we are supposed to meet. We're going to see how long until they kick us out. This week, ladies and gentlemen, for this week only, from 3:06 to 3:10, so you guys know, we're supposed to temporarily meet in E3, 325, okay? So that's only for this week. Now we're going to see until they come in and kick us out because they're supposed to do some work here. And that's starting today, 3:06 to 3:10. So, ladies and gentlemen, we'll see what they do. We're not supposed to be here, but maybe they'll start the work a little later or so, right? So maybe we get our class in. But I also want to say I have no idea if they have any Wi-Fi out there and how good it is. So what that means is for your lectures, you're going to want to be here physically in class. For those of you guys that are at home, I want you guys to know that, yes, and I'll send a message in Canvas, that for this week, I suggest you be here only because I cannot guarantee what the Wi-Fi situation is going to be in E3, 325. So, what's that? Oh, does it always cut off? Okay, well, there you go. The internet over there always cuts off. So I highly recommend, I'm going to say, come to what? Campus. I can record the lectures and upload them later, but, you know, it's not the same. So this is my recommendation for you guys. Come to campus for this week and meet in E3 325. I'll be there tomorrow morning, and it's for all my classes, so I have to let them all know. Okay, so just let you guys know. E3, where is E3 anyway? English, oh, that fancy English building? The nice English building? All right, so that's what's going on, and I'll send that as an announcement in Canvas as well. So, yeah, so that's what's happening. Now, what's also happening, I'm going to go back to my website. I did send an announcement to you. I believe I did. Yeah. I did my homework. In fact, I did a lot of homework this weekend. What did I say? I updated your homework to include some of the worksheets I have provided here for you guys. I'm going to share with you guys on that. So here it is in Canvas, graphing sine, cosine. Didn't I say I'd get some video solutions for the odds for you guys? Okay. And that is also here. If I go here, I went back to my old picture. Sorry, ladies and gentlemen. I get tired of looking at that other photo. And, you know, it's depressing when I see that. I go, wait a minute. So I'll go back to that photo. It wasn't that long ago. I have some health issues that are taking over everything. But don't worry, I should be back on track, hopefully. Okay, here we go. This is the worksheet here. So like I said, I created these worksheets to help us digest the section of 5354, you know, so it's not throwing us to the wolves kind of thing. And we're going to kind of ease into that, but it is something you guys want to do, your homework without a doubt. And I even did this. So what I did here, you're going to see answers, but you're only going to see answers for the evens. Okay? So you go, oh, those are the even answers? Yeah, but you also want to put some of those special points on that. Maybe if I get time, I can update it and locate those as well, those special points as well. But I do have video solutions for the odd numbered questions. And you say, where are they? It's right here below. And it'll be titled Video Solutions.
It's the absolute value of 3.
So I went through that at home this weekend for you guys. Okay, I didn't have a weekend. My weekend was working on curriculum and meetings. And so just let you guys know, I think it's important that instructors, when they ask you to work, that they work too. It means everything. You guys know what I'm saying? You don't want to be that kind of instructor that says, oh, you go do the work, but the instructor doesn't do the work. That's something that you experience back at those high schools. Trust me, I remember myself. I know what's going on. You know, that was always, and even sometimes that happens even here, just so you guys know. It's not just high schools, it happens here too. So you don't want to take an instructor that doesn't work. You guys know what I mean? You want something that does. Anyway, not only did I work, what else did I do? Here we go. I have these other worksheets, graphing tangent and cotangent. So I'm going to work on the odd questions, but I did provide even answers for you here as well. So we're going to work on some of these, okay? And just to let you guys know. Now, what else do we have here? Oh, the others, graphing. There should be some phase shift. Yeah, graphing sine and cosine with phase shift, and then graphing tangent, cotangent, phase shift, and then graphing secant, cosecant, blah, 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 blah. We're not even there yet. But I want to say I did some homework, ladies and gentlemen. Not just for you guys. I did it for the statistics class, too. I did a lot of work there for statistics. So my wife was like, am I going to see you? And I'm like, I don't know. I don't think so. So, and then yeah, that's the way it works, ladies and gentlemen. Trust me, it doesn't change. It does not change. You just started this stuff. But it's all good work, and it's all for a good reason. And like I said, I did my part, and it's going to be there in the assignment portion. And anyway, ladies and gentlemen, let's get started before they kick us out. Maybe they did. They're going to come and yell at us and say, get out of here, you know? And I guess if they do, we're going to have to get out of here. And hopefully that internet works. But starting tomorrow, we'll be in E3 325. And hopefully that internet's working. I'll try to, even if it's not, I'll just record these lectures. I even hope there's a projector there. Oh, my God. Do they? Some projectors, like in the classroom, they don't work over there? Do I have to buy a projector too? Somebody outside already throwing us out? Hold on, let's check. We might have to go see anyway. Buildings. Yeah. Well, remember when they come yelling at me, like when should I put it on mute? Put this on mute. When the chair comes yelling at me, I'll yell right back. No, I'm just going to let them know, oh, yeah, we have to go. That's it. Because we do. We have to get out of here, you know. So I don't know what they're going to do. What if they just turn off the whole power on the floor or something, you know? Then we'll know. And we'll just take it easy. You guys know what I mean? We just got to take it easy and, you know. But anyway, let's start with some of this stuff. Okay, so what I did also here, I'm going to start with this lecture so we can get something done. You know, whatever. This is called graphing tangent and cotangent. So we're going to do tangent first, the tangent function. And it has different formats here. Okay? So that's one thing you have to be be mindful as well. Now, I can show you in Excel like I did, and I don't think I'm going to. But here's kind of what this looks like, okay? You have this value here like you've had before. You see this A value. Now, that's not an amplitude, so you guys know. For tangent, we don't have anything. We don't have an amplitude. It's just a constant multiplied by tangent. It could be positive. It could be negative, right? And of course, we're going to look at situations where it's positive and it's negative. We also have that K value right here, okay? And K is going to be positive there. All right? So this is where we're going to start with this. Now, notice our period formula. Our period formula, ladies and gentlemen, is not the same. Period is the length of one cycle, but it's going to be pi over K. So be careful with that, right? So you have a different period. And I'm going to put that K value there. And like before, what you guys always want to do is get that interval of one cycle, because this is going to be, if I just went straight to tangent, your very fundamental tangent curve, I'm going to share that with you guys. Y equals tangent x. And I'm a little superstitious. I'm going to change that to a different color. Here's essentially what you're looking at. You're looking at tangent, and tangent also is periodic, meaning that behavior repeats itself all throughout what's called the real number line here, the x-axis. Okay? Now, if you went back and you said, okay, what's the deal here with the interval of one cycle? And yeah, we're only going to graph one cycle because we can't graph every one of those forever. And notice the interval of one cycle. It's very simple. It's another formula. That's an interval. It's negative pi over 2k to positive pi over 2k. So in this tangent curve, to let you know, that first tangent curve, k is 1. So the interval of one cycle is going to be from negative pi over 2 to positive pi over 2. And let's find that here. I have to start to show you guys that. Negative pi divided by 2 less than or equal to x. Ooh. By the way, this is Desmos. You guys may want to take a look at Desmos. It's a free website, and I think it's even a free app if you guys don't have it. Okay, so I work with Desmos. I've worked with this the whole weekend. This is an interval of one cycle. Okay, and that's kind of the picture of it. We'll make it bigger, and I always do these things called vertical asymptotes. We'll talk about what that is. So x is negative pi over 2. X will be positive pi over 2. And here we go. And here's my point to you guys. There's these things called vertical asymptotes. Do you guys know what a vertical asymptote actually is? What's a vertical asymptote? Well, first of all, it's a vertical line, sort of. And if you said, what did I just do? I made it dotted, right? I didn't put the solid line. In tangent, those lines are not there. Let me show you. They're not really there, are they? But there's these imaginary vertical lines here that your curve gets close to but never crosses. So you do have curves that have vertical tangents where the curve gets close to those locations, but they never cross. That's the tangent curve. And then notice this special location here, this point here. And this is in Desmos as well. Where's the parentheses? Here, 0, 0. And you guys are going to want to notate that point as well. What's so special about this point for tangent? Do you guys know? Well, it's not just the origin, 0, 0. What else is it? It's something special. We've been talking about it. It's an x-intercept. Good. So you always want to locate x-intercepts. Those are special locations on a curve. And also you're going to locate these vertical asymptotes. So in some ways, if you said to me, Mr. Judge, how do I remember some of this? You want to know what I do in my mind for tangent, the essential tangent curve? I go and I remember from algebra, you have a curve that looks like this. Let's see if you guys remember. See this x cubed curve? Let me change that color. It reminds me, tangent reminds me a lot of the x cubed curve. But the x cubed curve goes on forever. It doesn't have a vertical asymptote. It crosses that line. Okay, you guys see what I'm saying? It crosses. So in my mind, I can always remember tangent if I remember y equals x to the third power. It's the same kind of curve. How is it different though? Tangent, what? Never crosses those vertical asymptotes. That's the difference. So you can always memorize some of these curves, and it's a very important thing to do. You see, ladies and gentlemen, I have a worksheet, or I have a sheet called Curves Every B Student Should Know. These are all there. And if you're doing a STEM career, I highly recommend you do. You want to know these curves because you use them. And especially when you take other classes. Now, some of you guys might be taking like a pre-calculus course too. They have x-intercepts and they have vertical asymptotes in their discussions there as well. But I just want to let you guys know here, we're starting with the tangent curves, and this is all the information I kind of think about, okay? So here's my point. When you graph tangent, you kind of need to know really a few things. Number one, you just essentially are looking for the vertical asymptotes. You guys agree with that? These lines you never cross. And the x-intercept. You just need those two things, vertical asymptotes, the x-intercept, and you need to know how the curve behaves. You say, how does it behave? A lot like what? X to the third power here. And we're just sketching. That value of A is a factor, okay? But it's not really thought of when you sketch. Here's what I mean. If I put a 2 here, it makes it what? Thinner, okay? If I put a 1/2 there, it's going to make it what? Wider. That constant in front. If I put a negative sign, what do you think it's going to do? It's going to reflect it about the what? X-axis. You guys see what I'm saying? So Desmos, ladies and gentlemen, it's a free app. It's a free website. I've used it all this weekend to do all the stuff I was doing for you guys here. And I recommend it not so you guys can not do homework, but I recommend you can verify what you do using it. And it's free. And anyway, let's get back to the details of graphing this function here. Where is the location of the vertical asymptotes? In red, it's these endpoints here. Those are the vertical asymptotes. Okay? So this is essentially the analysis we're going to do for tangent. And this is kind of simple. Okay? So, all right, ladies and gentlemen, let's try the first one. And you say, okay, well, what's the first one? Well, they want us to graph y as tangent to x. Okay? Yes. Can I go back? Yeah. And also, what I'm going to say is this worksheet is in my what? It's on my website. And I'm also going to put it here for you guys here so you guys know. I'm going to put it right in here. I'm going to put it in the chat. You guys know? But it's also on my website. So you guys can download this yourself. Okay? That's what usually my students do. They download all the worksheets here. All right? So now, here's what we're going to do. For number one, let's get all the important information. Okay? Your K value is what? 2. Is that right? We don't really care about the A necessarily. A is 1. That's true. But you guys remember, we're not dealing with an amplitude. This is a tangent curve. So yes, we do care that A is 1, but it doesn't have any real, it's not part of the analysis. It is part of the curve though. But we just know this is regular tangent, okay? Now, how do we get our period? Remember, it's a different formula. It's not pi over 2k, it's pi over what? K. Now, what is K again? K is always the number multiplied to x. Always. And in this case, what's multiplied to x? 2. Good. So that means our period is going to be what? 2 pi, or pi over what? 2. Okay? Replace the K with 2. So there we go. There's your period here. Now that's the length of one cycle of tangent. So now you might say, okay, what else do I have to get? Well, what do they want us to do? They want us to get the period we just did. They need that interval of one cycle. What's the definition of the interval of one cycle? Right up in here. Right? As soon as you get, here's your definition. Interval of one cycle. So what you guys are going to do is you say, I know K is what number? K is what here? 2. Replace this K with what? 2. So now what is 2 times 2? 4. Okay. So the interval of one cycle is going to be, and I'll put it next to it, negative pi over 2 times 2 is 4. Positive pi over what? 2 times 2 is 4. There's your interval of what? 1 cycle. All right, you guys okay with that one? And guess what you guys know free of charge once you get that? You guys use this formula. Once, and I'm going to ask you guys on a test. What are the vertical what? Asymptotes, because we're going to draw those too. Vertical asymptotes, ladies and gentlemen, happen when x is what value? You guys notice? I'm gonna take a look. I don't know what color I'm going to use. I'm going to use red. See that first value? That's one vertical asymptote. You already have that number. You see the next one? That's the other vertical asymptote. You have that number. So what that means now is this. I'm going to write this down here, okay? Because I'm always going to ask you guys, what is the vertical asymptotes? It happens when x is what? Negative pi over 4, and then x will be what? Positive pi over 4, okay? So there we go. That's all the important information we need to do what? To graph our tangent curve. And it's tangent 2x. So, okay. So I'm now going to go over here to whatever I was at. Where am I? Here we go. And I don't know. I thought I had. It's okay. We're going to sketch this. I haven't figured out really how to save that photo here. Anyway, x-axis, y-axis. Now, remember this here. This is what you guys are going to want to do. I'm going to use all this information. Okay? Start with I always start with the vertical asymptotes. Now, this is somewhat symmetric. Negative pi over 4 is going to be to the left, okay? So here's what I'm saying. I'm going to put this like over here. Negative pi over 4. Then I'm going to put my what? Positive pi over 4, okay? And this is where those imaginary vertical lines exist here. Okay? And, you know, I'm not the best artist. It's okay. And then I want you guys to notice a special location. What's midway? What's midway between these two numbers again? What do we want to do? Graph the what? What was that point? The x-intercept. You always want to graph that. And that x-intercept happens when x is 0 here. So notate that as well, because I'm going to ask you guys that question. Hey, what's the x-intercept? It should be on the worksheet. Oh, it happens when x is 0. And ladies and gentlemen, you're kind of done. Why do I mean you're kind of done? What's left for you to do? You found all the important information. Interval of 1 cycle goes from negative pi over 4 to positive pi over 4. You don't include the endpoints. That's an open interval because at the endpoints you have vertical asymptotes. Period. The distance there between this is going to be really pi over 2. What do I do now? Do you guys know? I get to sketch my curve. How does that curve look? You get close to the what? X-axis, but you never cross. Goes up, and then you get go down here close to the what? Sorry, let me say that again. You get close to the vertical asymptote, but you never cross to the right and to the left. But make sure you go up and then down this way, because you got to know again the what? The way the curve behaves. You guys know what I'm saying? It behaves that way. What's my memorization device? I just think of this curve. Kind of looks a little similar. from like algebra or pre-calculus, x to the third. So, ladies and gentlemen, that's all you got to do. That is, you just graph that first tangent, and you say, what was that? Why was tangent 2x? There you go. That's number what? 1. Easy breezy, lemon squeezy. Right? Easy breezy, lemon squeezy, you guys. Anyway, let's go to the next one. You say, what's the next one here? Where are we at? We know what we could do? Yeah, let's go to the next one. The next one, number 3 here. Let me erase all this. Now for number 3. Okay. Now number 3, you got an A value, is that right? But remember, that A value doesn't really have, it's not an amplitude. It doesn't even have a definition. It's just a constant multiplied to tangent. But then, be careful here, ladies and gentlemen, right? We need the K value. And did anybody look at my video this weekend? You guys look at those solutions when I posted it up there? Do you guys get it in Canvas? Does it tell you right away? Anybody know what I'm talking about? I did this all weekend. What's K? Yeah, remember, this is K times X. Is that right? It's not X divided by K. So what does that mean about the K value then? What is K? This is 1/3 X. That's what K is, ladies and gentlemen, when you have this X over 3 here. All right, you guys okay with that? This is number 3. So let's see what's going to go happen now here. So then you say, is my period still going to be pi over K? Notice that every time I use it, what do? I write it down. But that's pi divided by what now? 1/3. You say why? Because that's the value of what? K. Okay, you guys okay with that one? That's K. What do you guys think? Not too bad? So pi is going to be, or period is going to be pi divided by the K value. And how do you divide a whole number? You multiply by the reciprocal. So what's this going to be? What's your period? Period's going to be what? 3 pi. There you are, ladies and gentlemen. So you got the period there, okay? Now, the interval of one cycle. What's that definition? Right up here for that interval of one cycle. It's negative pi over 2K and positive pi over 2K. So I'm going to put it here, negative pi over 2. What's K? 1/3. Positive pi over 2. What's K? 1/3. And you close that, ladies and gentlemen. Okay? So focus on this arithmetic. This is really arithmetic here. Okay? So you go, what is that? Well, that's negative pi over, isn't that really divided by 2/3? And positive pi divided by what? 2/3? You guys with me on that? Easy breezy lemon squeezy? Wrong button. But how do you take a whole number now, like a negative pi? This is divided by 2/3. So what do you think that is? Isn't that negative pi times what? 3 over 2, which gives you negative 3 pi over what? 2. So the other value will be simply the same arithmetic, but it's going to be what? Positive. This, ladies and gentlemen, I'm going to put this down here. I'm going to put this over here. This is your interval of one cycle. This is the I. And once I have this, what else do I have? Vertical asymptotes happen at negative 3 pi over 2 and also at what? Positive what? 3 pi over 2. This is the important information we need. All right, you guys okay with that? All righty. So what I'm going to do now here again is this. I'm going to copy this information again. And I'm going to go back here to the other sheet. No, not here. Where am I going? Over here. Oop, no, that's calculus. Sorry. There we go. And let's remember, this was number 3, right? And number 3, we're graphing y equals, I think it was 1/4 tangent of x over what? Is it x over 3? Okay. Okay. X-axis, y-axis. Okay. What do you guys start with again? Start with your what? Go to the left. Yes, the vertical asymptote. 3 pi over 2. Go to the right, the same distance. 3 pi over 2. What is midway between those vertical asymptotes? Yeah, it is 0, but we call that what? The x-intercept. Good. So you're going to graph that x-intercept, ladies and gentlemen. And then you're pretty much done. That happens when x is 0. Just sketch your what? Tangent curve. You get close to that axis, but do not cross. You get close to that vertical line. I apologize, but you do not cross that line. And now you're looking at what? Tangent. Yes, the 1/4 is a factor in how it looks in the curve, but we don't have to what? Sketch it. Okay, easy breezy, lemon squeezy. Not too bad. You're going to follow your format. You're going to follow your formula. You're going to graph this tangent here. All right, let's see. What's number 5 now? I scroll down, number 5. Let's get that pretty big. Oh, they went straight to what now? Number 5. We're looking at cotangent now. Okay. Now, so let's look at the attributes of cotangent. You know, they got y equals, well, I'm going to do this here on my sheet. I'm going to write down cotangent here. Yeah, I'm going to show you guys as soon as I write it down. A cotangent kx. Okay, as soon as I write it down. There you go. Okay. Now, the attributes of cotangent here, this is what I'm saying. A is not an amplitude. It's only for sine and cosine. Cotangent's another story. You still have kx again. Okay? And what I'm going to say now here is this. For cotangent, your period, if I go back to that worksheet here, now they're saying, look at cotangent. Yes, k is going to be positive. We know. Your period is the same formula. It is pi over k. Where this changes is you have a different interval of what? you got a different interval of 1 cycle, ladies and gentlemen. It goes from 0 to pi over k. And again, your vertical asymptotes are going to be from x goes to 0 and x goes to pi over k now. Okay? So this is the only difference right in here. And I don't know what to... Yeah, let's look at that there. Okay? And that's going to change your vertical asymptotes. And then if we go back again to Desmos and just look at a regular cotangent curve now, okay? Y equals, I think it should have it. Yeah, there we go. Cotangent just of x, okay? Let me get rid of this. Let me get rid of this. And I'm going to get rid of this temporarily. And I'm going to change the color. Change the blue. Cotangent is also periodic, okay? What does periodic mean? You repeat this pattern forever, to the right and to the left. So it just happens over and over again. So it's going to be periodic behavior. But didn't we say it has a different what? Vertical asymptotes. Instead of at negative pi over 2, it's going to be at 0. Okay. And instead of at what? Positive pi over 2. What do we have over here? Do you guys remember in our sheet? What was it? Go back. Let's see if I can. There we go. Pi over k. So that's just going to be pi now. So, okay. So I'm just going to put pi here. So it's 0 to pi now. And I'm going to put this restrict the domain. So we can just focus on the interval from 0, less than or equal to x, less than or equal to pi now. So this is the restricted domain, okay? So that's 1 cycle. That's the interval of 1 cycle from 0 to what? Pi. The asymptotes are at x is 0 and x is pi. But what you want to know something about this. This changes. Cotangent's a little bit different. You say, what do you mean it's different? Cotangent, ladies and gentlemen, this is shifted where? Where's your x-intercept? Do you guys know? The x-intercept is the midpoint of the interval from 0 to pi. So you know where that means that this is going to be? What's midway? How do you get midway? From 0 to pi. 0 plus pi is pi. Divided by 2, this will be pi what? Divided by 2. So we're going to notate the x-intercept as well. And then, how do you guys think that curve behaves? Do you guys know? What's the memorization device you want to use for this curve? You see the x cubed? You can say, that's not x cubed. But if I put a negative sign in front, do you guys see my point? So in my mind, I think of negative x cubed reflected about the x-axis. Yes, it's shifted. But that's what I want to bring up to you guys. So that's kind of the details for cotangent. So I want you guys to note the x-intercept is going to be midway between 0, well, plus this value. And then you go, is that pi over k divided by 2? Yes. Is that going to be pi over k times 1/2? Yes. The x-intercept is going to be at pi really over 2k. But just always get the what? The midpoint. That's all. Midpoint, midway. Now, they don't want us to look at the curve of just cotangent in this example. What do they want us to do, right? You say, they want us to look at, this is number 5. They say y here for number 5 is what? 2/3. Cotangent 1/2 x. Okay. So we're going to have to do all that work again. And you go, what work? Okay. 2/3, yes, that's an A value, but it's not an amplitude. Because this is cotangent. Amplitude is only for what? Sine and cosine. And then, you know how nice they were? They give us that nice K. Is that right? K is what here? 1/2. Is that right? So period is going to be pi over what? K. So this will be pi divided by 1/2, pi divided by 1/2, or simply pi times 2 over 1. What's my period, ladies and gentlemen? Your period is what? 2 pi. Okay, so I want you guys to get all of these details here. Okay. Do you know the definition of the interval of one cycle? Wasn't that 0? You start at 0, and where do you end? Pi over what? K. Is that true? This is for cotangent. Start at 0, and where do you end? Isn't that the same as the period? Double check. Yeah, isn't this P? There's your P. It's your period, ladies and gentlemen. So, okay, my interval in one cycle is 0 to what? 2 pi. All right, good. Now we should be happy here. You say, why are we happy knowing that interval? Because if we have the interval, we have the vertical what? Asymptotes. X is 0. X is what? 2 pi. Easy breezy, lemon squeezy. Okay. So that's the information we need to graph what? 2/3 cotangent, 1/2 pi. All right, so let's get out the what? Your x and y axes. Here's my x-axis. Here's my what? Y-axis. Okay, so what do you guys start with? Remember, what do I start with? Where are your vertical asymptotes at? 0. Where's that? Where's 0? 0 on the x-axis is down there. Is that right? So I'm going to put that imaginary red dotted line, and then it goes to what? 0 to what? 2 pi. Another imaginary red dotted line. Okay. Do you guys remember how to get midway? How do you get midway between those two numbers? 0 plus 2 pi divided by 2. What's 0 plus 2 pi? 2 pi divided by 2. Why do I care about this point? My x-intercept is where happens when x is pi. So I want to notate that as well. Because what do I have to sketch? I got to sketch what? What's this function? Cotangent. What's the memorization device for cotangent for myself, ladies and gentlemen? I look at that and I think negative x to the third. Right? So if you're taking pre-calculus, they're going to have you sketch those too. Intermediate algebra, you sketch them as well. Anyway, how does that look? You go down and you get close to the vertical asymptote, and then you go up and you get close to the vertical asymptote. You never cross them. And guess what, ladies and gentlemen? You did it. You graphed what? You say, what about that A value, 2/3? Well, it is a factor in the curve, but we're not really notating that at all in the sketch. Okay, and also remember, you got the vertical asymptotes and the x-intercept here. Important locations. And there you go. Okay, 0 to, what was 0 to what? 2 pi? 2/3 cotangent 1/2 x. What about in Desmos? Two-thirds cotangent 1/2 x. Is that right? Is it 1/2 x? I already forgot. Interval 1 cycle went from what? 0 to 2 pi, I think. Okay, is that right? And then 0 to what? 2 pi, I think. There we go. Let's get rid of that curve here. And then pi is the location. There we go. Isn't that the curve we're looking at? All righty, ladies and gentlemen. So what do you guys think you want to definitely do? You see that piece of information? That's your guideline. Is that right? You want to know those definitions. They help you sketch. Without knowing that, you're not going to sketch anything. Is that right? So that's what I would start with. Anyway, okay. All right, now let's see. Number what? This is number 7. Y equals negative cotangent 2x. This is the a value. If you have the negative sign, what does that mean? Do you guys remember? What does that mean? Any negative sign in front of a curve or in front of the function, what does that mean when you graph it? It's reflected about the what? X-axis. And again, now, what's k here? K is going to be what? 2. Must be kx. So, ladies and gentlemen, your k value is 2. Go to your definitions, period, for tangent. And isn't this pi over k? Well, be careful. Is it pi over k or pi over 2k? I don't remember. What does your format say? Period is what? For cotangent? Uh-oh. Oh, I think I got to go up here. Cotangent, what is your period? Pi over k? All righty. K is 2, is that right? So there you go. K, 2. So guess what that means? You already know the period. Period's going to be what? 0 to what? Pi over 2. What's that interval of 1 cycle going to be? Because it's cotangent, it's really 0 to what again? 0 to p. So it's 0 to what? Pi over 2. And this gives me my vertical asymptotes. X at 0 and x equals what? Pi over 2, ladies and gentlemen. Easy breezy, lemon, what? Squeezy. Know these definitions here. This is a cotangent curve. Okay, so when you start to graph, it's very simple. Graph the what? You're going to have your symmetry here, or I'm sorry, your xy Cartesian coordinate. X-axis, y-axis. Again, you want to find where the vertical asymptote is. We already notated that. It's right here. X is 0. over here. And x is what? Pi over 2 over here, right? Just kind of sketch it. This is just a rough sketch. Do you guys know how to find a midpoint again? What do you do to get that midpoint? What's it going to be? Pi over what? 4. Good job. See, doing that arithmetic over and over again, what does it do for you? You start to go, okay, 0 plus pi over 2. You guys see how we did that? Then divided by 2, that's going to be pi over 2 times 1/2, which is pi over 4. All right, now we have the x-intercept. We're going to want to know that location. Happens at x is pi over 4. All right, now, what do you think we do? We got to know the cotangent curve. What's your cotangent curve? What's that memorization? Negative x to the third. Is that true? But what do you guys know about a? Be careful here. That's already negative. What's minus a minus? Plus, what do you think that means? Think of x to the third then. See the opposite of that minus x curve? Minus x looks like this, right? Isn't that the minus x curve? But if I have to reflect that curve about what? Don't I have to reflect it about the x-axis? Because there's a negative sign already in front? So if I reflect that curve about the x-axis, how does it look? Looks like this, going up forever, and then going how? Down forever. So that's why I say to you already, what's minus the minus? It's going to be what? Isn't that the x cube memorization device? So then I get to get rid of my reference curve. And ladies and gentlemen, there you go. You just graphed what? Number 7. What do you guys think? Is that okay? Number 9. Let's see what number 9 is. Number 9. Y equals negative what? 4 tangent pi x. All right. Now, before we go back there, let's go back to the tangent information. Okay? We have a different interval of 1 cycle. Is that right? Okay? You guys see what I'm saying? But you got a period. The period is the same. So when I read this, yes, this is the a value. I'm going to put it in red because it's negative. I'm going to have to reflect that curve for tangent. Is that true? You know what I'm saying? How does a tangent, what's the memorization device for tangent? So, Mr. Judge, that's x to the third power. What's it going to be for the minus? Minus x cubed. You guys okay with that? That's how I'm going to look at it. And, okay, what's your k value, though? What's k? Is k pi? The definition of period is pi over what? K. So what's that going to be? Pi over what number? Pi. What's that going to be? 1. So, ladies and gentlemen, my period is what? 1. So I'm going to give you guys a few seconds to try this one out yourself to get started while I send out an announcement to a couple of classes. Okay, we'll give you guys some time here. See what you guys can get. Okay. All right, let's try this out, ladies and gentlemen. Okay. Remember, what's your interval of one cycle definition going to be? For tangent, it's negative pi over 2k to pi over 2k. Is that right? What's k again? Pi. Here, here. So you're going to put pi here. What does that give you guys, right? What does that do? You got negative pi over 2 pi, positive pi over 2 pi. What happens with the arithmetic? Don't you cancel pi's, right? So what's the interval of one cycle? Negative 1/2 to what? Positive 1/2, because there's a 1 here and here. So there you go. Okay, you guys okay with that one? So double check that work there. Okay, you guys okay with that? All right, now, number what? Or not number. Let's do this here. X-axis, Y-axis. Let's kind of move everything over if we can. Alrighty. Okay. So, what does this also give us? What's the vertical asymptotes going to be at? X is what? Negative 1/2, and then X is positive 1/2. Is that true? Okay, because the second you get that interval of one cycle, you know the vertical asymptotes. Okay, so let's plot that down. Negative 1/2, positive 1/2. Negative 1/2 is to the left here. Positive 1/2 is to the right over here. And then you're going to draw your vertical asymptotes. Okay. So far, so good. You guys okay with that one? But what do you do now? What do you guys remember? This is tangent. Tangent's the x cubed, but there's a negative in front, so you're going to have to graph negative what? X cubed. Is that true? All righty. So let's remind you guys, where's the x-intercept? Because you can't graph that negative x cubed unless I have the x-intercept, right? Where's the x-intercept going to be? How do you know it's at 0? Right in here. Because midway between negative 1/2 and positive 1/2, midway between those vertical asymptotes, right? What happens when you add those two numbers? Don't you get 0? Then when you divide by 2, isn't that 0? All right, good job. Now, sketch the negative what? X cubed. And my pictures are not that nice. And there you go, ladies and gentlemen. This is how you graph number what? Number 9. Is that one okay? What do you guys think? When do you guys want to get started in your graphing homework? Last week. Okay, number 11 here. What's number 11 say? How does number 11 work? Y is 2 cotangent. Y is 2 cotangent what? 4 pi x? Okay. Alrighty. Yes, you have an A value. But what is your value of K in this question here? What's K? K is 4 pi, is that right? So the period pi over k, which is pi over what? 4k. What happens to the pi's? They cancel. Isn't there a 1 there? So my period's going to be what now? 1/4. So, ladies and gentlemen, this is kind of nice. What kind of curve is this? Is this cotangent? Okay. What do I have to remember there? Minus x cubed curve. Is that true? With the graphing. But I also want to, what's the interval of one cycle for cotangent? It's not the same as tangent. What's your interval of one cycle for cotangent? Isn't it 0 to the period? Because no, isn't that 0 to p? Yes, it is. 0 to pi over k. That's the p. Okay. So with that, I know 0 to what? 1/4. Okay? It's the same p. What does that mean? Vertical asymptotes happen with x is 0 and x is 1/4. All righty, you guys ready for this? So we're graphing cotangent, and now, again, we have to have that x-intercept and the what? The y-intercept. Let's move this over. All right. So remember what I want to start. I have to start by plotting the what here? The vertical asymptotes. They happen when x is 0 and when x is 1/4. So I'm going to go to the right here. Okay. Don't forget the x-intercept. Isn't the x-intercept halfway? What's halfway between 0 and 1/4? What do you guys know? Do you guys know what that is? 0 plus 1/4 is 1/4. What's 1/4 divided by 2? 1 what? 1/8. What curve is this? Isn't this cotangent? Meaning you're going to sketch what? Negative x to the third power. Okay. So that looks like I'm going up, getting close to the vertical asymptote, going through the x-intercept, and then going down. Sorry, I can't see, but anyway, going down forever. Let's draw it nicer if we can. Something like that, ladies and gentlemen. That's minus x to the third power here for my cotangent curve. What do you guys think? Easy peasy lemon squeezy? Alrighty, go to number what? What is number 13 going to be? 3 tangent? Oh, 3 tangent what? Negative, is that negative x over 6? Is it 4? Oh, 4 for, sorry. I'm looking at the wrong number. Okay, thank you. Alrighty. All right, and then you're going to say, Mr. Judge, I thought you told me that k is going to be positive. Does anybody remember what do you guys know about this tangent curve? Is tangent even or is tangent odd? Why can I pull out the negative sign? What do I know about tangent? It's what? odd. Do you guys remember? So what does that mean? It means I pull out my what? Negative sign. So now my a value is negative. I'm thinking of the tangent curve. Tangent curve is going to be what? We know it's x to the third, but that negative sign makes it negative x to the what? Third. Is that true? So I'm just going to notate that now. And then again, my period is going to be pi over k. However, what does that mean? I need kx. What's k? That's 1/4 x. You are right. It's always the constant multiplied. So k is 1/4. So you might now say, well, what does that mean then? If k is 1/4, then that's pi divided by 1/4, or then my period is going to be really pi times 4/1. My period is really what? 4 pi. Okay? Now, be very careful. You say, why be very, very careful? Is this the tangent curve? Say yes. Interval of 1 cycle for tangent, what does that look like? It's negative pi over 2k and what? Positive pi over 2k. So this is why I mean be careful and go back and look at what? At the definition of that interval of 1 cycle. Okay? And if k is 1/4 now, you're going to have to put that 1/4 here, 1/4 here. Okay? 1/4. What's 1/2 of 1/4 though? Right? If you do this arithmetic, that's 2 times 1/4. 2 times 1/4, because that's what k is. What's 2 times 1/4? It's negative pi over 2. Right? Isn't that 1/2? And then what does that mean? What's my interval going to be? Negative 2 pi to what? Positive 2 pi. Isn't that what happens when you divide a whole number with a fraction? Okay, you guys okay with this? So if this is my interval of 1 cycle, what do you think that means then about our vertical what? Asymptotes. What are the vertical asymptotes? X is negative 2 pi. X is positive what? 2 pi. So just be careful about that arithmetic. And we get to sketch our curve. So remember, where do we start with this? What are the vertical asymptotes? Negative 2 pi, positive 2 pi. So go to the left somewhere here and say that's like where negative 2 pi might be. Be symmetric. 2 pi. Draw those vertical asymptotes again. And what's midway between 2 pi and negative 2 pi? 0. Outstanding. We're almost done. So the x-intercept happens when x is 0 here. And what kind of curve do we draw? You say, oh, this was really a negative a in front, right? Negative 3 tangent, which means that was tangent x cubed, which means we do the negative what? X cubed, ladies and gentlemen. Okay? Negative x cubed looks like this. Oh, what? You go up forever, and then you go how? Down forever. And there you go, ladies and gentlemen. There it is. So I do want to remind you guys again that on this worksheet here, I have the graphs for all the what? The answers for the what? For the evens, and we just did the odds. So I want you guys to finish that off for homework. And where will we see you guys tomorrow by any chance? E3 what? 325. Hopefully things work out for us, okay? See you guys later. Take care.